Hello class, this is for today's lesson 4.1. Okay, we're going to learn about basic graph. So for the basic graph, it basically we have 4 of them we will learn so far, but we will have 2 more later on. So the first is for y equals sine x. Y equals sine x is from 0 to 1 to 0 to negative 1 to 0. And you can see there are 2 hum here. Okay, 2 hum is one sine graph, and each portion here in the broken line is also this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, quadrant 4, didn't write that well. So each quadrant counts at 90 degrees. Okay, each portion 90 degrees here. So that's why the power 2, pi, 3 power 2, and then 2 pi. Where did they get this from? They also take the cycle divided by 4. So it's equal power 2. So that's why each part is a power 2. And the signs also bounce between 1 and negative 1. For cosine, they basically almost the same as sine, except they start from 1 to 0 to negative 1 to 0 to 1. And then again, each quadrant is 90 degrees. So they also from 2 pi, the cycle is also 2 pi, so one cycle is this one cycle here. So that means cycle means every 2 pi they repeat the same pattern. And then your cosine x between 1 and negative 1, same thing. And the next graph for tangent graph. Tangent is the cycle for tangent is a pi, not 2 pi. So that means every pi they have a one shape. Okay, every pi they have one shape come out. So if I add a pi here, okay, and then my graph is going to be like this. So every pi, so this is 3 power 2, so add a pi here. Then they're going to repeat the same graph. And this is the 0. And they don't have a restriction on the top and the bottom, so they can go as high as they want to, go as low as they want to. But the only restriction is right here. So every pi, they have a one graph. And half them, so they divide by 2, they don't divide by 4. When you graph, they divide by 2, okay? So that's why power 2 and then negative power 2. And one more thing is that I forgot what I want to say. Yeah, for every pi they repeat the cycle. Oh yeah, one more thing is this is quadrant 1 here, and this is also quadrant 4, okay? And then for cotangent graph, this is a cotangent graph. Number 4 is a y equal cotangent graph. Okay, cotangent graph, they start from 0 and to pi, and then the graph will exactly flip as a tangent. Okay, they come down here, then this power 2, they intercept. And then you can see that if they add another pi, they get another cycle here. Okay, there's a 2 cycle here. So this is a 2 cycle. So this is 2 pi. But the cycle is a pi only, means every pi they repeat one cycle. You can see pi there one graph, another pi there another graph. Exactly same graph. Now we're going to use this one to do some exercise. Okay, use this information to do some exercise. And the first exercise we're going to do is problem number 26. You are given cosine x equals 0. They said in the cosine graph, which part you're going to get x equals 0. And well, let's look at this. Okay, they only want one cycle for the answer. So you said basically which angle will make cosine that angle equals 0. That's basically your x-intercept. So be right here and right here. Okay, so your x equal power 2 and then 3 power 2. And then the next problem is number 28. So I'm going to erase this and go number 28. This time they ask you cosine x equal to 1. They said which angle will have cosine x equal 1? Well, cosine x equal 1 is right here. 1 and 1. And you drop down the angle, that's a 0, that's a 2 pi. So your x equals 0 and 2 pi. And so let's try one more. Okay, let's try number 30. They said cotangent x equals 0. And x equal to what? Well, cotangent x equals 0, right here, right here. They want the answer, again, they want the answer between 0 to 2 pi. So that's the power 2, and then what? 3 power 2. And let's look at number 34. They said cotangent x equal to undefined. Undefined, that means asymptote, okay? And where's your asymptote? It's what? Right here, and right here, okay? So that'd be 0, pi, and 2 pi. And they only want the answer from 0 to 2 pi. So that's how you do this part. The last thing we're going to learn is even odd function. And I told you guys a little bit before, but in case you forget, so we're going to we do it again. So even function is a cosine that's the even function, okay? Odd function, now same as secant, so I didn't write it. Cosine, odd function is for sine. Okay, so your negativity, the negative come out, but this is negativity, the negative is gone. And then we have tangent also. And this is useful, okay, even odd function pretty useful. So let's look at number 38. We have cosine negativity 135 degree. Well, by the even function, it just equal to cosine 135 degree. And that means cosine 135 is right here. And that's what? 45. So that's same as a cosine 45. Because the cosine this side is negative, so we're going to put a negative sign. So that's same as cosine square root 2 over 2. Okay, so that's how you use this even odd function. And let's try one more. It's a point number 44. Sine negative 7 power 6. Sine negative 7 power 6, we're going to divide these to 6 parts. And I told you guys before. Okay. So we take 1, 2, 3, 4, 5, 6, and we take 7 of them. So we need one more out. The one more out is your reference angle, power 6. So that means this is same as sine power 6 negativity. Okay. Maybe I write one more step. This is same as a negative sine 7 power 6. And same as negativity and negative sine power 6. Why negative sine power 6 here? Because you're in quadrant 3, so for sine it's a negativity. And so that becomes sine power 6. Well, power 6 is same as a 13 degree. And because 6 and 3 are they kind of like friends to each other, so 6 and 3 are correspond. So these just equal 1/2. And the last thing we're going to do is to do a proof problems, okay? Do a proof problem. So this odd function, I erased it accidentally. And so we're going to do an odd problem. That will be proof problem number 15.4. We're going to prove cosine minus theta, cosecant minus theta, tangent minus theta equal to 1. So we're going to use the property on the top, okay? Cosine negativity is same as cosine positivity. Cosecant negativity is same as a negative cosecant theta, because cosecant same as a reciprocal sine, okay? So they behave just like sine. Tangent just equal negative tangent theta. These two negative become positive, and cosecant equal 1 over sine. Tangent equal to sine over cosine. And now we're going to start reduce, because this means over 1 here. So this is reduce, and we get 1. So that's what we want to prove. Okay, so that's how we do in 4.1. So make sure you do your homework. And we're going to do 4.2.